All right. Good morning, good afternoon, depending on which coast you're from. My name is Layron Walker, and Connor will come up soon. We're with a company called Sciberus. We're a software development company focusing on building creative experiences using AR, VR, and mixed reality. Today, we're here to talk to you about a cool project we worked on in partnership with Niantic and Playcraft, which focused on the integration of combined AR shared meshing, and want to show you this. We call this project HackAR, right? Because it was a little hackathon. We spent about 2 weeks kind of going through it. And the cool thing about this is that at the end of the presentation, we'll give you access to download these bits and kind of play with them and use them in your project. So let's talk about the big idea. HackAR is a game where essentially you have these 4 players that are coming together in this combined environment, and they're playing against this rogue AI. This AI is trying to destroy the world, and they have to use a combination of real world and the real world environment. They have to use their skills to fire these projectiles to kind of help to kind of kill this AI. And at the end of the day, we keep track of who actually is involved in this presentation or this conversation to build a leaderboard to kind of proclaim a winner. And you can see some of the animated GIFs in the background showing some of the gameplay. Now, what's cool about this is that everything we have here is empowered by Lightship ARDK. So by a show of hands in the audience, like, are there developers in the audience? Or perfect. Have you guys built experiences using Lightship in those platforms? Perfect. And so as you know, Lightship is an amazing tool in that it provides you with a couple of key things. One is real-time mapping. So historically, we use a lot of ARKit, AR Core, and AR Foundation, and it gave us access to surface-level plane detection. And for the most part, we could place our AR into a scene. We could use it for interactions, but we weren't really aware around the environment. And so ARDK addresses that because it gives us access to not only the polygons on the surface level, but it gives you access around this 3D context. So that's one thing that was really important here. The second thing is the shared AR experience. Most games are collaborative. So in this case, we use ARDK's SDK to make sure we can keep track of game state and to make sure people can play in the same environment. We didn't necessarily leverage semantic segmentation just yet in this game, but I put it there as a core feature. But last but not least, since our game is based in Unity, having access to this kind of multiplayer SDK, cross-platform SDK was really powerful. And so let's talk about the game. So one of the first things we have here is we have a lobby system. And so what happens here is that you can spawn a session, you can create a code. That session creates a join lobby that everybody can join the same session, and that allows you to kind of be in the same experience to share information. Once you've kind of scanned and got into that session, in the second piece, you have to localize and scan your environment. And so in this case, the host goes around, they start to scan and build their mesh to become aware of their environment. And on the flip side of it, other people do the same thing. And so now you kind of built this combined experience that's being connected, allow you to interact in the same place. Then last but not least, what happens in the third screen, you'll see where we're playing this game, we're interacting with the environment. As we're scanning, the mesh is continuing to build itself out, and we're kind of playing and interacting with it. And at the end of the last screen, you'll see that after 3 or 4 sessions, there's a leaderboard that shows up. So it's a pretty cool experience. On this next slide, and I kind of walk through some of these things, so there were a couple of key rules. One, we had to have it be networkable with multiple people. So in this particular case, we allowed you to play with up to 4 players. You can play by yourself. You can play with 4 people. And the cool thing about the game is that in the rules engine, as you add more people, it gets more complicated or more harder to kind of complete the task. And on the next screen, what I'll do is I'll show you a brief run through. It's about a minute video or so, very quickly to show the entire gameplay to kind of get a sense of that. So let's watch that. So here you see in the top left, player 1 and player 2 are green, which means their environments aren't stable yet. When the host becomes stable, every player becomes stable, you can now start the game. So now the player is about to touch and place the AI in the scene, and you'll see it kind of show up very soon in view. And then it's there, and then the host says begin operation. So once that happens, the game commences. Now, each player now is able to fire their targets. And as they're firing their targets, you'll see these projectiles that are coming back toward the person. So the idea is that you have to move around the environment to avoid getting hit, right? So there are 2 key rules here. If you get hit, you kind of lose your health value. Your system crashes for a few minutes or so, a few seconds to kind of commence again. And then more importantly, the AI is moving up and down to make it a little bit harder for you. If you bounce off a wall, you maybe get more points. And also, there's kind of like a region of importance where if you go within a certain circumference of the enemy and you get too close, it tells you must kind of step back so you're not cheating. You're just right up on top of it. So all that's happening back and forth, as you saw there. And at the end, you saw the lobby manager come up and show who won the game. And what's cool about that is that as a part of the ecosystem, as you see some of our core features, which Connor will start to talk about in a second, at the end of the day, even though we had this localized version and the rules were all being handled locally, leveraging Lightship's networking object allowed for us to be able to share that game state to kind of project the winner and have you work in this decentralized but centralized manner. So that was pretty cool. So now I want to bring up Connor to talk about some of the technical pieces of the program. He's going to walk through some of these features and kind of dig a little bit more details on that.
Hello, everybody. First of all, thank you for having me. Glad you guys could all be here. My name is Connor McClellan, as Laren stated, and I was one of the two Unity developers that helped put together HackAR over the couple-week period with the hackathon. So as Laren stated earlier, we used a couple of core concepts from the ARDK package to build together this game, and I'm going to be going over a little bit more in depth on how we use them, sort of what was given to us originally from the ARDK package, and how we tweaked it to make it our own. So the first thing that we noticed when building the game was that originally the lobby system was tied exclusively to the AR session. So in most games, like you've played, you may have to go join a lobby, you're still in a waiting screen, a loading screen, before you get all your players in, and then you sort of launch into the game. We wanted to do something exactly like that. So to do that, we had to break apart Niantic's lobby manager system and make our own so that we could split the creation of the AR session with the actually joining the lobby. So to do that, we had to make our own custom lobby manager, which utilizes the IA multi-peer networking object and sort of just splits across a lot of their actions and events happening. So once we do that and we launch into the actual shared AR experience, the AR multiplayer class and the AR networking manager is what helps us combine that, the two meshes from each phone's, or more than two, if it's a 4-player game, to localize into one mesh together and actually join these two players into the same AR experience together. And then once we do that, we have to sort of worry about, okay, we're both in an AR session together. Now we have to worry about, I have a player, I have an enemy, and both my player and my enemy are going to be shooting projectiles. So how do I keep track of who's doing what in the game? And am I listening for what the enemy's doing, or am I telling everyone what the enemy's doing? We go over that with the, I'm going to go back here for real quick. We go over that with any object that's created and network spawned. You have to tell them, do we have authority of this object? Which means, are we telling everyone else in our AR scene where this object is, or are we listening for what that object is doing? So what we decided to do when creating HackAR is split up the networked authority so that you are only in control of what the individual player has, aside from the host, which is also in control of the enemy. But we did that to sort of break up all the networked calls and not have everything be bogged down on the host. Because what we found with some testing is that if everything's on the host, their phone sort of has to handle a lot of processing power. So we decided to break that up amongst each individual players. You can see when we do that, when we spawn a networked object, every object has to override the setup session method here. And what we do in the third line down there, the owner auth try claim role, is determine whether this object was spawned by me. And if it was, we give that object authority, meaning that that object is going to tell all the other peers in the session where that object is. We're going to tell it its transforms and any other sort of data that we need to do, or if we're going to be an observer and listen for where the transform is or any other objects. In this case, in most of our game, a lot of it was just getting our transforms to line up, but the one thing that we did do is send over a health roll for our enemy as well, as that needs to be pretty stable between all users. And one of the other key functionalities that we brought into this game was using Niantic's persistent key value storing. And this is a system that you can essentially tie a value with a string and send it up to the, Niantic on the cloud side. And for the entire persistence of the AR session that you have, you can then reference down those values from the string that you sent up with it. So what we use this for is our leaderboard, or our scoreboard at the end. And how we do that is when the game starts, we break down each player number and tell the cloud that we want to store excuse me, the player number with originally a 0 value, just so we have everything initialized. And then, as you can see on the next screen, when we update the score here, we're going to add however many points we just got, which is variable based on how much bounces our projectile does, and then just send that up, serialize it as we're sending it over over the cloud, and then locally we're going to say, hey, I just updated this value, and all the other peers on the network is going to now on the bottom here call on persistent key value updated, and it's just going to pull down that score to whatever we just changed it locally. So when looking at all this, once it's built and done, we have to take into account sort of what kind of performance we just got, because this was, for us at least, the first instance that we used for shared AR, as well as the advanced meshing that Niantic's put out here. So performance wasn't really that bad. We did get some bogged down when it came to maybe having the session open for around 10 minutes or so, anything past that. What we did find is that the GPU was running at pretty much maximum capacity almost all the time, although keep in mind this was made on an iPhone XS, so not quite the most up-to-date technology, but still something that should be pretty capable of running AR. We didn't really get any memory spikes. The only time I could see it spike was when we first created that AR session, which makes sense, but nothing else was being too bogged down towards the end of the, through the rest of the session. You can see here on the thermal state, it's all pretty serious. So as you keep playing this game for longer and longer, your phone's going to heat up. So you're going to want to be aware of that. Probably when you're implementing this into your own games, try to keep game time down, just so you don't end up with a smoldering device in your hand. But you can see on the very top line here, the system load, which towards the end of the game, what we do is we have different phases throughout the game. And as you progress through these phases, the enemies start spawning more and more projectiles at you faster and faster. So you can see every time it sort of hikes up there, that's when we're going into the next phase. We're spawning more objects, and the system load just has to handle all that. So that's increasing with that. But if you're just in a normal session, say you're just walking around a park or something and you're looking at something that you spawned, you probably won't have too big of a deal. If you're spawning a lot of objects, that's when you'd want to worry about that a bit more. So to wrap things up, I'm going to bring Laren up here. We're going to talk about the key learnings and then open it up for a bit of a QA.
Thank you. Cool. All right, cool. Well, thank you, Connor. Your part was much better than mine, so I appreciate it. Just let you do the whole thing.
Debatable.
Cool. So a couple of key learnings that we did. As you imagine, one of the key core components of this is the meshing piece, where you have to find a way to make sure that these multiple users can scan in one environment and kind of work within the same ecosystem. The cool thing is that Niantic does a lot of that behind the scenes for you, so it's not this big, crazy physics problem. But figuring out things like lighting or location, even in some cases, as we'll try to show in a live demo later, when you're trying to scan and localize, depending upon the orientation, what's happening behind the scenes is that the host is kind of localizing first, and then when the peers are trying to localize behind the scenes, those things are trying to be overlaid and mapped together. So you can imagine if you're trying to scan a room and Connor's looking at the TV and you're looking at the wall, having those things kind of collide together will be kind of hard to do. So keep that in mind as you design your gameplay, and the approach is really important. He mentioned the ownership of network objects and what happens with that. So today, to keep the CPU down, like he said, we distributed the labor out. So as he mentioned, the host controls the enemy, a lot of the game state pieces, and we also have the host only controlling the entire mesh. So everybody's using kind of the host representation of the mesh. Another opportunity could be where that object could be spread out amongst multiple people, so they can kind of own and control their own mesh. The challenge then, though, is that in some cases, when you put those things back together, it could cause load issues, et cetera. So that's one thing as well to kind of keep in mind as a key learning. And lastly, performance. As he mentioned, we had a slew of devices that we tried, some older devices, some newer devices. We even, as well, tested some Android, high-end Android phones, and things kind of just work. But keeping in mind kind of the type of device that you have. In this case, we noticed even this morning trying to scan in here, his iPhone is one of the newer iPhones that has LiDAR. So of course it's going to localize faster versus older devices, right? So keeping that in mind as well is critically important as you're kind of thinking about how you approach things. But those are some of the key learnings. But all in all, it was a very pleasant experience. Nobody lost any hair besides me, but it's been gone for 10 years now, and we kind of got through it a little bit. So next, we're going to do two things. We want to open the floor to questions, and we also are going to try to get a live demo going at the same time to kind of show the game being played. So if you have any questions or want to ask any questions while we get that set up, there's a microphone here. So please come to the microphone, ask your questions as we kind of work to get the demo set up. So please don't be shy. Come in and ask any questions you have.
Hi, good morning. Thank you for this awesome talk. It's a very interesting problem of multiplayer data, sharing multiplayer data across multiple players. I guess the question I have, and maybe I came in late, so maybe I might have missed this, is how do you handle sharing physics data, like colliding funny fireballs and
Sure.
machines and balls? Because that's probably a lot to calculate at once. How do you handle that multiplayer? Thank you.
Of course, that's actually handled fairly locally. What we do is, as long as you have that same object, it's going to be in the same place for everyone. So you can take care of those physics calculations locally. Say you're worried about an on-trigger enter event, something like that. As long as it's moving at the same place, it's going to call on-trigger enter locally, so you don't have to worry about, say, a networked event where you're telling it to, say, like spawn certain effects at a certain location. That sort of stuff can all be handled locally. We're just telling it to be in the right place at the right time.
Got it. So just sharing the position data, so the transfer.
Exactly.
That's, okay,
Yeah.
awesome.
Yeah.
All right, great. Thank you.
Of course. Thank you.
Hello.
Hello.
I was wondering, what do you think contributed to such high GPU usage? Do you think it was just the depth mesh, or do you think it was computation or something else?
I think it was more leaning towards computation, as we saw it pretty much correlate with the length of the session, and the longer we go, the more, the faster responding networked objects. So in my opinion, it's pretty directly correlated to how many networked objects are in the scene, and how many things are we trying to tell each individual user, hey, make sure this is at this particular location.
Okay, cool. Thank you.
Yeah.
Hi, great talk.
Thank you.
If you had more time, like another 2 weeks, like in terms from your learnings, what would you do change about the gameplay? Shorter duration, that kind of thing. Like what?
So as Dan can attest, we originally came out with this having a slew of feature creep, and we had to cut it down pretty drastically. What we had originally planned is the enemy relocating between rounds, and even more than that. And also, we had a mechanic in called Black Ice, which would be something where we take the mesh data of all the users and create an area where if you stand in it, you're going to not be able to shoot, essentially. Similar to how the enemy's projectiles, when they hit you, your system is shut down and you can't fire anymore. So doing things like that, as well as we had another mechanic where we were trying to have everyone be an individual agent, and they'd have different abilities, such as one person would be able to create a wall as you do more damage by bouncing off of your surfaces. So, hey, might as well make someone create a surface. So we were thinking of that, but just within our original scope was 2 weeks, and then we had, I think it was another 2 weeks to document and do a little bit of bug fixing. We had to sort of ease that a little bit back down, but there's certainly a ton of cool things you can do with this new technology. So I encourage each and every one of you to go and try it out. So.
And to add that as well, I think in the piece when you're scanning and localizing, finding a way to put a visual so you can be clear on what part of the word has been scanned, so it makes localization a little bit faster.
Yeah.
I think that visual piece will be helpful as well.
Gotcha.
Yeah, we found a way to sort of have your local mesh have a texture, but not a way to have the combined mesh to have a texture. But
Gotcha.
yeah.
Just to follow up,
Yeah, of
did you
course.
guys use the mock editor in your process at all?
We didn't. We were stubborn with that. We sort of looked at it and was like, this may be a little bit too much to work in, as we weren't familiar with it.
Sure.
Now looking back on it, I'm like, we definitely should have used it. Seeing how many times we built just to change one thing, and
Sure.
that could have just been not a thing we had to do.
Sure.
So
Sure, yeah.
yeah, I encourage using the mock editor. I've since set it up, and it makes life a breeze. So
Thanks so much.
of course, thank you.
Any other questions? All right.
Any other questions?
All right, cool.
Awesome. We're going to get started with our live demo here, and if any other questions do arise as we're playing, we're going to be trying to explain through the process as well. If any other questions do come up, please just feel free to ask and interrupt us if you want. So, is that me?
That's, I think that's me.
That's you. Yeah, I'm still waiting on it. You want to just have one?
That's cool.
Okay.
It's not showing up. Pull down. There we go. He's trying to get his reflector going. So notice I just spun the game, and I put in my network object, and Connor will come up as well.
Hopefully.
There we go.
There we go.
Cool. So he's going to put in the same code.
So once I join the lobby, we see there's 2 players here.
So now I can start the game as the host. And I'm going to start trying to scan to localize now.
And we can see each individual player's statuses up on that top corner.
So hopefully we localize quickly in a live demo.
Yeah. This all depends on lighting, unique features. We found what device you're on,
There we
what
go. So
sort
I'm
of
stable.
camera you have. Really impacts it a lot. One thing that helps out with localizing is if you're looking at things from the same angle. So
Cool.
you see I came over here and I'm
So
stable.
now I can place the AI in the scene. Let's see. Where is he? There he goes.
Yeah.
Oops.
You can move it around too. I think it's behind you right now.
Where did I put him at? Hold up. There you go. I lost track of him. I'll just hit it again. Do you see him?
It looks like he's a little bit right in front of you. You may be too
Okay.
close to
Let's hit it again and see what happens.
Yeah, you may just end up being too close.
You see him? He's not there. That's not gonna work. Let's do it over. Lab demos are beautiful, huh? All right, let's do this again.
I swear we did this 3 times before this. Use a different code.
Okay.
So one thing that also came up is when you leave a session, it's going to still be there for about 30 seconds after. So you'd want to be
I'll
wary
use my name.
of. What'd you choose?
Layering.
Layering, gotcha. You want to be wary of if you leave a session, immediately try to rejoin. It's going to sort of rejoin into that somewhat broken session afterwards.
All right, redo.
While we're localizing, any other questions?
There we go. So I'm stable.
Yeah. And once again, it helps if we get about the same viewpoint, try to look at the same thing. There we go.
Perfect. Now let me mess it up this time. So put them there and begin operation.
So one thing we didn't quite have a video of is if I get too close, I get a proximity alert. I can't fire.
Proceed.
That's what we brought in to try to help people not just stand right on top of the enemy and just
So
fire.
we can't move
Yeah.
much here because of the stage. I don't want to kill myself. But you notice as we're scanning, it's aware of the environment, so I can bounce off the walls, I can bounce off the floor, and kind of go through it, and kind of keep things moving. So it's pretty interactive to promote movement, gameplay, and fun.
If anyone says I'm bad at my own game, I'm blaming the width of the stage here. I can't exactly dodge
Oh, he
away
got me.
away from things.
So, yeah. So again, you keep playing. They're roughly, anybody want to try it? Come on up. Or did I stop it? 2 minutes? You got 2 minutes, I'm sorry. So, yeah, I'm sorry about that. We'll catch it outside.
Take your time.
TV time.
Yeah, we'll be outside after this if anyone does want
So
to
let's summarize things up. So to that point, as you just saw, cool example, things work, very excited by it. Had a lot of fun building the app and kind of using it. In the future, in other apps that we're working on, we've already started to work on bringing ARDK into our platform. We built a platform called Mimic, which is an augmented reality dance app that lets you interact in the real world. And so Connor's already made a version of Mimic that has replaced our AR core, AR kit pieces with Lightship ARDK. We're looking at segmentation to come inside of there to start interacting with the cool videos and things that are in the scene so that people can make really cool videos. And we're very excited as well about bringing into forward things like VPS to kind of extend that out. So had a lot of fun doing this. I'm sorry, another question?
Oh yeah, I was just curious, like, you know, it's sort of a specific setup process. There's some specific nuances to how all of it works. Like, obviously it was a really fast turnaround for the project, but
Sure.
like, moving forward, how do you think about teaching new and inexperienced players how to like do that very
Got it.
specific setup process?
Cool. So one thing that is not clear, we actually have published an entire blog post that walks into how to use this. We don't have the exact public location yet, but if you connect with us, we'll get it to you after the event. But the full source code will be available. We actually created a Unity package, and we talk about all those. Every key learning that we described here is described in a blog post, so that you could just download it, use it, interact with it, and get real full feedback from there.
Yeah.
Yeah.
Wow. Sorry. Go
Yeah,
ahead.
my question is more about like, you know, the UX experience of like signing on as a new player,
Got
not
it.
necessarily
Oh,
as
I
a
see.
dev, but yeah.
Yeah. Okay. Another thing that we didn't highlight as well is there's a piece in the app as well that walks you through the steps that make that happen. So over time, building out more experiences, help videos, et cetera, will be there. But there's some contextual screens in the app that explain the concept, the gameplay, and how you leverage it as well.
Cool.
We didn't highlight it today.
Cool. Thanks very much.
Thank you.
Of course. Thanks.
And one more question?
Yeah, I was just gonna ask if you know, depth messages often aren't complete or have holes in it. How did you deal with that?
What was the question one more time?
Depth messages often aren't like fully complete as you're scanning them, or there's like holes in them, especially for like LiDAR meshes. So how did you compensate for that, or did you just let stuff like?
There's some numbers you can tweak of how precise, or the distance between the points in the mesh that you can change around. We messed around with that. We saw with a little bit more precision, you get more precision, but it bogs down the device a little bit more. We saw frame rates drop when we did that. But it's sort of a trade-off that you have to do when you're looking for either something super precise or super accurate or fast, or like when we did that, our phones were getting so hot that we didn't want to play through the entirety of a game. So it's just you have to keep those things in mind. There is an option to sort of tie down the precision of the mesh, but it comes with pretty drastic trade-offs in my opinion. So we just kept it fairly stock, for the best word, for what it came with, which was I think around like 1.5 inches, centimeters, whatever they use. But yeah, so we did that. One other thing that helped is just to really make sure you get a in-depth scan. We didn't end up implementing this, but I'm pretty sure what you can do is check the like area of the entire mesh that you have before you start the game. So what you could do is force someone to have a larger mesh, which just means more scanning time, but a larger mesh before you start, so then hopefully you don't have those holes or any inaccuracies.
Cool, thank you.
Of course.
Thank you guys for your time.
Thank you guys.
Appreciate it.